And okay, so we're good. So hi everyone, my name is Summer Grooms. I am an instructor here in the professional trades department. We're kind of a small department. There's only a few of us full-time faculty. Albert Rosner and Eddie Burkhead, you might have had them before. If not, if you're new to this department, you'll probably see them in the future too. So pretty small department, but yeah, it kind of occupies a lot of different industry specific pathways. So a lot of you taking this course, some of you might be on the pathway to become an electrician. Some of you might be on the pathway to get a certificate in manufacturing. Gosh, what are a couple of the other options? Manufacturing, electrician. Sometimes it's, certain associate's degrees or just industry specific certificates, or you might have to take this through your employer. So there's kind of a wide variety of students we see in this course. And this is ELT 106 is definitely kind of an introduction course to electricity. And the end, we get into a little bit of maintenance related activities. So we talk a little bit about like welding and some manufacturing related concepts. But it's a pretty fun course, I think, but I'm an engineer, so I have a kind of weird sense of what fun is. So I don't know. If you like school and trades, then you might like this course. So a little bit about me. I am an engineer by trade. So I actually just recently started being a full-time faculty member, but prior to that, I went up in Alma. So I worked in Alma for a while as a safety coordinator. So I worked at a manufacturing plant and just oversaw like their safety program. And then recently I worked for the state of Michigan for a couple of years regulating large water systems. So Jackson included. You guys have really good water if you've ever wondered. But yeah, so that's kind of what I did. I'm an environmental engineer, so a little bit different than an electrician, which is a lot of the courses I teach, but engineers and the trades kind of go hand in hand. So that's kind of how I ended up here. But I love to teach and I love my job here. So it's been great. But yeah, so this is a totally online class. You're not required to come to campus at all. But with that in mind, you are more than welcome to come into my office hours whenever you want. If you have any questions, concerns, I am here to help you however I can. I know it can be difficult sometimes in online courses. I've been there where you don't really know who to communicate or how to communicate, but here to tell you that you all hopefully have my email and have been getting my emails, and please don't hesitate to reach out any time of day. So I know a lot of you work kind of off shifts. You might be up odd hours of the day. That's totally fine. You can send me emails any time of day. I have a little one, so I'm up just about any hour of the day. So you might, if you send me an email at 2 a.m., you might be surprised that I respond at 2:15 a.m. too. So don't worry about that. You can respond or you can email me anytime. I set in Canvas, there's a Calendly link. I'll put it here in the chat too, where if you want to schedule office hours with me, either in person or online, you can do that using the link, or you can email me. But all in all, main thing is, don't get too stressed out about this course. And make sure that you know that you have support. So however I can help you, I am here to help. So please don't hesitate to reach out with anything. Okay, so I'm going to share my screen and talk a little bit in specifics about how this course runs. It does run a little bit unique to other courses you may have taken here, and that is because this is a CBE style course, or competency-based education course. So essentially what a competency-based education course means is that it's really focused on individualized learning. So what that means is all of you that are starting here come in with different levels of expertise in various topics. Some of you might be very advanced in some of the topics we talk about. Some of you might not know anything, and that's okay. This is an intro course. But towards the end of this course, the goal is that all of you are at the same point and you all have the competencies learned in this course that you're supposed to. So with that in mind, with this being a CBE course, it's essentially kind of like a pass-fail course, meaning that you have to pass all competencies in order to pass this course. We can't technically have pass-fail courses at Jackson, so the way that we kind of work around that is essentially there are only 3 letter grades that you can get in this course. 4-point, which hopefully all of you get, a 1-5, and a 0-point. And this is outlined in the syllabus here that I'm going to pull up. Actually, I should pull that up now so it makes sense with what I'm talking about. So my screen should be loading here in a minute, and I'll talk through everything here on the course, but you'll see that the syllabus is located right here under getting started. And I know I just jumped out the gate and started talking, but I will save time at the end for any questions. So if you have any questions, you can ask them at any time, of course, but I'll make sure to save time at the end. Okay, so basic information, 3-credit course. We meet on Tuesdays, 12 to 1. There's my email, which all you should have. Course description, a little bit about this course. I kind of talked about that a minute ago, but you can, give that a read. If you have questions, let me know. These are the course objectives. So there's 4 course objectives. So with that in mind, there's 4 competencies or kind of 4 sections of this course. So competency A is all about electrical theory. That's what we're going to focus on for the next couple of weeks. And then we'll get into the other competencies as the 7 weeks progress. So this is what I was talking about. I'm going to go with the grading procedure. So you can see here, that's a little bit unique to what you might have seen before. So a 4.0, a 1.5, and a 0 are the only grades you can get from this course. I know this looks intimidating to see that if you get anything less than 100, that you potentially get a 1.5 and fail the course. But the thing with this being a CBE course is that you basically have 7 weeks to master everything, and you have unlimited attempts. So really, it isn't stressful because you're going to be able to take the exams. There's 4 exams. You're going to be able to do the project and submit it multiple times, and essentially, do it once, see what you got wrong, and then you can come to these and we can talk through what you got wrong, and I can help you get to that 100%. So it sounds intimidating, but it's really not, because you have unlimited attempts, you have my help, and you have all the resources online. So the goal is that all of you get a 4 points. So it really is kind of nice in the sense that hopefully it's you all get 4 points, and that helps your GPA. So that's my goal, is to have everyone master all the competencies. I do not want to hand out any 1.5s or 0 point. That's not at all what I want to do. So however I can help you achieve that 4 point and that 100% and help you achieve an understanding of the competencies is, I'm going to help you in any way that I can. So so that's kind of how the grading procedure works. As for attendance for this course, this is also really important. So with this being an online course, sometimes it is difficult for me to navigate kind of who is still actively enrolled in the course. So because of that, you must be active once a week on Canvas completing material. You also have a couple milestones that you have to reach, and there's a milestone schedule we'll talk about in a minute here. If you miss a milestone, because I understand life happens and some weeks might be busier than others, that's okay, as long as you complete a quick survey that I have in Canvas, just letting me know when you're going to finish it. You just can't miss 2 milestones in a row because there's only 4 of them. And if you do miss 2 of them, I'll probably just drop you from the course, not to be mean, but just because I'll just assume that you're no longer taking the course if you get that behind. Of course, if there's like extenuating circumstances or reasons where you get really behind and plan on catching up, send me an email and we can walk through that on an individual basis. So really, this is just kind of a way to track, who's still actively taking the course. So main things are just stick to the milestones. If you can't reach one, complete the catching up survey. The rest of this, a lot of it's, pretty straightforward. I'll let you read it on your own. Reach out if you have questions. At the bottom here, you'll see this is the schedule of kind of what to complete when. So you can see that there are 4 parts. This course, A, B, C, and D. So competency A, B, C, and D relate to the 4 competencies in the course objectives. So this is kind of the guide. You can see that for the next 2 weeks, we're going to be working on part A. Then we'll move on to part B, part C, part D. And then the last couple of weeks of this course, the idea is that you kind of refine everything until it's at a 100%. So I'll talk more about kind of the final project and the final exam, but just going to pause here and see, are there any questions about the grading procedure, the attendance, attending needs. Any questions, concerns at all that anyone has? Okay, not hearing anything. I hope that means that all of this made sense, but if not, let me know. Okay, so you should see back on my screen. Let me just stop sharing for a minute. Make sure it goes back up. So let's kind of walk through Canvas here. So this is your basic Canvas screen. If you've never taken an online course, this is where all of the material for 106 is. You want to see it says I-51 here. There's two sections, I-50 and I-51. So if yours says I-50 here, it's fine. You're in the right spot too. Zoom link, all of you know where that is because you're all on here, so not worried about that. This Getting Started tab, this is a lot of important information. So you can see that catching up survey. So again, you'll complete this if you miss a milestone, like if you miss a deadline or you are going to miss a deadline, submit that beforehand. And again, you have to submit that if you do miss a milestone, just because if you miss a milestone and don't, I'll assume you're just not taking this course anymore. And when I go to take attendance, it'll probably automatically drop you. So just be mindful of that because I don't want to drop someone who's still planning on completing it. The pacing guide here, if you click on this is just going to show you kind of what you should do each week. So you can see that week 1 and week 2 are all doing part A of the project and part A of the final exam, which I'll talk about here in a minute. Important milestones. So again, these are those deadlines. So by the end of week 2, you should submit competency A and complete the exam with a passing grade. And again, a passing grade is 100%. So that's going to be, I'll put the actual dates here just so you're clear, but that'll be June 15th, that first deadline. So by June 15th, you have 2 weeks to basically do part A of the project. You can get as ahead as you want. So if you finish part A, it was all easy to you, and you want to get started on B, C, D, you could technically finish this course in, a week if you wanted to. It's totally individualized, but at the bare minimum, you have to do it by these dates. But you can work as ahead as you want. So it's flexible in that regard. Okay, so a little bit about those final projects and final exams. So this right here, this tab, this is what's required of you. So you can see that there are 4 parts of the final exam. So again, the 4 competencies. So this competency A, this is the one that's due June 15th, along with part A of the project. So competency A, you'll see that there's 19 points. So that means there's 19 questions. And a lot of the questions are just introduction to electricity. So this competency A is about electrical theory. So the next 2 weeks where I'm on, either I'll try to save time at the end of today's to talk a little bit about the material here, but especially next week, on Tuesday, we'll talk a lot about competency A, and I'll really try to target some of the questions they ask just to, help your understanding more too. So next week, definitely I would encourage you to hop on because we'll talk in specifics about this part of the course. So these are just multiple choice questions. Again, you can take these as many times as you want until you have 19 points. It should tell you which ones you got wrong, but it's not going to tell you the right answer, of course. So kind of what I always recommend, especially if you do come into this course with some background information, take an attempt at this quiz today or tomorrow, see where you stand, see what questions you got wrong, maybe write a note of them. And then as you go into the course, you can kind of target your learning for those questions, right? So for example, let's say you take this quiz and you get all the questions related to power correctly. As you go into the material in competency A, you don't have to watch these lectures. You don't have to do this learning module, because if you already know that material, then you don't have to do it. So that's kind of the benefit of this being a CBE course. Really, the materials that you use and the resources you use that are given to you are individualized. So if you don't have to watch all these videos, you don't have to do any of these, really. It just depends on what material you need to learn. And of course, you have an instructor, right? So every week I'll be here on Tuesdays to talk through this content and to give an overview. Again, I'm going to highlight some of the exam questions, highlight some of the project questions to help you out. And of course, come with questions too. So if there's something you continually are getting wrong on the exams or the projects and you don't know, that's your time to ask, and I can kind of talk through it and make sure that you understand it. So really, I think that I'm hoping that I'm explaining this well enough that you see that it shouldn't be stressful, but the idea is that at the end of the 7 weeks, all of you will have a very thorough grasp on the material that you're supposed to understand for this course. And that's kind of the idea too, with a lot of the courses in our program are moving to a CBE style. And the benefit of it is at the end of the course, you know, we, us as instructors, we talk to a lot of, you know, industry specific, you know, like partners, and we can tell them what you learned in this course, and it's consistent. Everyone learned this course because everyone mastered the topics. And also you all, if you know, have job interviews, or if your job
Somebody didn't like their food.
if your job is requiring you to take this course, you know, you can kind of pull it up and show them exactly what you learned, and you can say that you mastered all the competencies, right? Because by the end of this, hopefully you all have 4 points. Okay. So as for the final project, this here is the template for it. So if you download this, it'll show you the questions. So I'm going to download this just to show you. Hopefully my screen switched so you can see the questions here, but you can see that it's broken down again into the sections. So there's 5 questions for competency A. So these are the 5 that you'll want to answer by June 15th. And with all of these questions, I am totally not picky on how you submit it. So for example, if you want to create a video and talk through all 5 of these because you don't like to write, that's fine. If you want to write it down on a piece of paper, take a picture of it and send it in that way, that's fine. If you want to type it up, that's fine. However you want to submit this is totally fine with me. As long as you have the right content, right understanding, you'll get the point. So these are the 5 questions again that you'll want to answer. As for submitting it, you'll see that there is a submit here. And again, you can submit this multiple times. I'll grade it multiple times. So you'll see that there's this rubric here. So when you submit it, typically it takes me maybe 3 days to, oh gosh, I graded this as soon as I can, but within at least 2, oh my goodness, sorry, oh, there we go. Like does that all the time. It's so frustrating, but I'll grade it within 2 to 3 days. So if you didn't get a grade back and you obviously want to grade back on it because you know what you have to maybe go back and fix, so shoot me an email if it's been more than 2 days, and I'll grade it that day usually. Because again, this is also the portion that you have to have 100%. So you'll see that on your end, I don't think it'll show it on mine. There'll be a submit button. You can just submit it. And for example, like you can submit part A. When you finish part A, I'll grade it. If you get them all right, you can move on to part B. If you have one question wrong, you can just resubmit it. You don't have to resubmit the whole thing. You can just resubmit that question, if that makes sense. So essentially just submit it as multiple times as you want. I'll grade it as multiple times as you want until it's at 100%. So with all this in mind, definitely when we get to the end of this course, you want to make sure that you save, you know, time for me to grade it in case you still have things that you have to fix. So that's why if you look at the pacing guide, by week 5, I would have all of this submitted at least, and then you have a couple weeks to kind of refine it. And if I grade it and there's a couple that you have to go back and fix, you have plenty of time to go back and fix it. So you'll see that the pacing guide says that to finish this by week 5. And then of course, if you have everything correct by week 5, then you end the course a little bit early. So that's how that works. The textbook here, this is just a supplemental resource. So I know some of you are like to learn best that way by reading a textbook. At least that's how I learn best. So you can access that. And then of course, for each competencies, there's a couple of these lectures. If you click on these, it'll open up a YouTube video on that specific subject. They're about 5 to 10 minutes long. So again, if you take the exam and take the project or look at the project and see that what questions you're stuck on, it kind of can help guide what lectures to watch. Alongside these, here are amateur modules. Essentially, the way that these work, if you click on one, this one's on basic electrical circuits, it'll open up a pre-quiz. You have to take the pre-quiz if you want to just like I just submit this sometimes and then so I can start the learning material. You can do that. It won't count towards your grade, of course. And then you can click on this launch button. And essentially, this is like an online simulator. So you can click on the objectives and it'll bring you right to that. There's a way to turn off the sound somewhere right here, because I don't like the sound because it makes me mad sometimes. So you can turn it off right here if you don't like to listen to the voice talking. But you just kind of scroll through. It's a little bit less dry than a textbook. So some people like to, learn this way. And it is interactive. So you can see like this multimeter. You can actually, as I like move my mouse, it's changing the voltage. So there's like little interactive pieces of it. And then at the end, there's a quiz that is also good practice. A lot of the questions on the quiz may kind of relate to some of the quizzes on the exam. But again, this isn't counting towards your grade. The only pieces that count towards your grade are that final exam and final project. Anything else you do is just for your own knowledge. And yeah, that's kind of how the course runs. So like I said, the next 2 weeks, we'll talk about competency A. So for the rest, maybe 20 minutes or so, I'll talk about competency A and some important concepts of that. And then, main things, just stick to this milestone schedule. Make sure you understand the concept that you have to get 100% on all 4 of these exams and this final project, but you can submit it multiple times. And that's really the main thing for the course. And then just make sure that if you miss those milestone schedules, that you complete that survey. Let me know kind of when you're planning on completing it. But beyond that, main things really just reach out if there's any concerns. I know that a lot of you, this might be your first online course, maybe your first course here at Jackson College, but really I'm here to help you any way that I can. I tend to respond that same day. If I don't, sometimes it goes to my junk mail. If I don't respond right away and you need an answer, send me another email and I'll respond hopefully to that one. So yeah, hopefully this isn't too stressful of a course, but hopefully at the end, you learn a lot of good information. So with that, I'm going to take a break before diving into the content and just see if there's any questions, concerns, anything that I didn't explain well that anyone wants to ask. Now is your chance to do so. Not hearing anything. So I'm really hoping that means everything was clear. I'm hoping it means I didn't confuse any of you, but because I know it can be kind of confusing, right? If you've never taken a course that's CB style, but I think it's all good. I think it's a positive change. That's the goal. So, okay. With that, I'm going to talk a little bit about competency A. So first things first, let's look at some of these questions they ask. So as I mentioned, competency A is all about electrical theory. So if you look in the syllabus, it'll give you a little blurb about what that is, but essentially it's talking about kind of the main principles of electricity, main concepts to understand, main definitions. So you can see here that for this competency, a lot of the questions relate to the components of a circuit and the terminology related to electrical theory. So for example, question 1 wants you to draw a simple circuit and label a couple of the components. We'll talk about this today. And then the other couple of questions relate to voltage, resistance, and current. Those are 3 fundamental terms to electricity. And if you've ever heard of Ohm's law, those are the 3 terms that are used in Ohm's law, and they come into play in almost every electricity course you're going to take here if you go on to take more. So it's definitely important to understand what those are. So I'm going to pull up my slides here, and like I said, we're only going to talk for I'll save 10 minutes at the end for questions. So I'll only talk for 20 minutes. And then next week I'll pick up where we left off in competency A. So you should see my slides here. Start at the beginning. This says 120. Let's change this to 106. I promise it's the right content. Okay, so main things first are, what is electricity? So essentially, electricity is a form of energy resulting from the existence of charged particles. And with meaning charged particles, typically we talk about electrons. So electrons, if you remember back to chemistry that you maybe took in high school, electrons are those negatively charged particles in an atom that kind of move all around, kind of surrounding or orbiting the atom. So essentially what electricity is it's the movement of electrons. So you can see here that this is a simple depiction of kind of how a circuit works. So essentially for a circuit, you start with a source, typically that battery source. This is kind of what powers your circuit. You can see that a closed circuit means that you have a pathway from one end of the battery to the other. That pathway is what those electrons travel through. They can't, just to create electricity, they can't just travel through midair. So essentially there's a wire. So wire is kind of the conductor, the medium through which those electrons are traveling. So they have to go from one end of the battery to the other. There's something called a load a lot of times in circuits. A load is kind of what you're lighting up. So in this example here, or in most examples, when you see a simple circuit, the load is just like a light bulb, indicating when those electrons are moving along this circuit or moving along this pathway. Once they get from one end to the other, they're going to hit this load, go through it, cause it to light up, give it electricity. Switch is exactly what it sounds. A switch is exactly what you see when we turn on and off a light. It's turning off and on an electrical switch. When a switch is open, there is no electricity. When a switch is closed, there is electricity. So I would say when drawing a basic diagram of a circuit, so in that problem 1 question, this is how I would draw it. So for a basic circuit, when we're drawing it, we typically draw it as a square just because it's easier. This positive and negative sign and this symbol here, where you have like the dashed lines, indicates a battery. So a battery is, again, the power source that kind of powers our circuit, and that's where your electrons are stored. So a battery we know has a positive and negative side. The electrons will move from one side of the battery all the way to the other, and that's kind of what powers electricity. So this here is depicting a load, right? Your light bulb. So again, this is what you're trying to get to be energized in your circuit. A switch here, typically on a circuit, is denoted by like this open door. You can see right now that this door is open, meaning that the switch is open. And when it is open, electricity cannot flow. And that's because electricity needs a closed pathway to go. So our electrons are going to start from one end of the battery and move all the way to the other end, right? Well, when this switch here is open, those electrons are not going to be able to complete the pathway, right? So you'll see here that they can't go through. So when that switch is open, they're not going to be able to complete a whole pathway, meaning that this light bulb's not going to light because they're not going to have a full pathway. So that's the importance of a switch. And that's why in your house, a switch turns on and off the lights, because it's turning on and off the power essentially. So that's kind of how a switch works. So again, this is kind of what I would do when drawing it. So as I mentioned, a battery, that's kind of that source of energy. So that's what provides a push to push those electrons through. So the strength of your battery is going to dictate how big of a push those electrons get, or how big of a source of energy they have, which is why we have different size batteries. Batteries are something that are measured in voltage. So that kind of introduces the first term to you here, which is voltage. So voltage is the push or the pull that kind of moves our electrons. A couple other things we've already touched on, but just solidifying here. So I always remember close equals flows. So when a switch is closed, that's when electricity flows. So circuit must be closed for your electrons to flow. When it opens, that's when electricity is going to stop or turn off. So as I mentioned, there's three important terms when introducing electricity, and that is current, voltage, and resistance. So current is something that is measured with the symbol I. So I had to look that up once because it didn't know why it wasn't C. And I think it's mostly because C must be taken by something else. But the I actually comes from like the French term for current. It's like intensity. Oh, it's something like that. So if you're wondering where the I comes from, that's why. But you just kind of have to remember. It might be nice to either take a screen share of this or I can send it to you just to remember because you'll see that in some of the quiz questions. And in some of the equations we're going to use, it'll say I. And so it can be kind of difficult to remember that's current. There's no I in current, but it comes from intensity of some French term, I think. Okay, so the units for current are measured in amps, and that's abbreviated by A. So for example, they might say this current in this circuit is 5A or 5 amps, and that's just giving you the unit. Voltage is measured in volts, and the unit is V. Resistance, symbol R, it's measured in something called ohms, and the abbreviation is this little horseshoe. So to kind of talk a little bit more about these terms and specifics, I already mentioned voltage, but the voltage, again, this relates to your battery, right? And it's that push or the pressure that's moving your electrons. So without a voltage in a circuit, your electrons wouldn't have any push to get started, right? So that's why voltage is such a fundamental term when talking about circuits. And essentially, it's how much energy exists to move electrons from one specific point to the other. So the greater the energy there is, the greater your voltage is going to be, or the greater that push is going to be. So as I mentioned, current is measured in amps, and essentially what the current is it's the speed at which your electrons are going through the wire. So if we go back and look here at the circuit, our electrons are moving along this pathway. That pathway is the wire. How fast they're moving is the current. So you might get a couple questions on the quiz that say like, what is the current in a circuit with a 5-volt battery and a resistance of 10 ohms? And there's a way to calculate that, which we'll talk about. And finally, the last term is resistance. So resistance is measured in ohms, and essentially resistance is the measure of the opposition to current flow in an electrical circuit. The best way that I think of resistance is exactly what it is, right? So when we think of like resistance, it means to like oppose something, right? Like if you're pushing against something and it's giving you resistance, it's opposing that force. That's what resistance is. So resistance is the opposition to current. So that's what is essentially working against current. And resistance or adding resistors into circuits are really important because we want to be able to sometimes, when we're designing circuits, manipulate them, right? So if they're going too fast, we can add resistors to slow it down. So resistors are really important to add and to be a part of circuits. So again, it's just the opposition to current. There's a lot of factors that can impact resistance. So things like the length of the conductor, again, which is the wire, the medium through which those electrons are traveling, the type of material you have. So sometimes you might hear of like an iron conductor or aluminum. The diameter of your conductor, which is typically something measured in the gauge. So you might have heard of like different size gauge wires, right? Like a 12 gauge wire is the typical wire size of a house. So that's essentially just how wide around the wire is. The load might impact your resistance. So again, the load is what you're trying to get energized in your circuit. In most examples, for talking about like basic electricity, it's just a light bulb. The only thing that doesn't impact resistance is the strength of the power supply. So that doesn't have an impact. And again, you can add a resistor in a circuit, and that's going to kind of manipulate or decrease or increase your resistance. The more resistors you add, the more resistance you'll have in the circuit. So as you can see here, this bottom bullet, the higher your resistance, the lower the current flow. And this makes sense, right? Because resistance is opposition to current. So it makes sense that the more resistance we have, the more it's going to slow down our current. You have to be careful here because there are safety concerns if we have either abnormally high or too low. So if abnormally high, it could cause corrosion, which is essentially like the wearing away of like the metal, or it can damage your conductors due to burning and cause, fires and safety concerns. So it's definitely a balancing act when designing circuits. So now this brings us to Ohm's law. And Ohm's law is essentially the relationship between these three terms. And this is, one of the fundamental equations in electricity. And again, if you go on to take multiple electrical courses here, we're going to use this same equation in multiple courses. So essentially, again, it's a relationship between voltage, current, and resistance. You can see that the I there is for current. And all it is this equation here. So V equals I times R. And then you can write it, of course, for I and R, depending on what you're trying to find. So essentially what this means is if you have two of the three terms, you can solve for the third term if you're given the other two. And that's what a lot of competency A wants you to learn, is just basically using simple math to find either voltage, current, or resistance. And we'll do a couple examples here in a minute. The other important thing to note is how increasing one of these parameters is going to impact the other. So they do have a relationship with one another, and we'll talk about that in a minute as we do a couple examples. So the way that I like to talk about Ohm's law is by showing this chart. So you can see here that this is essentially this. It just also has power. Power technically isn't a part of Ohm's law, but there are equations that you can use to calculate power, so it's easy to kind of lump it in together. And power is part of competency A, so it's nice to talk about. So you can see here that these are the four terms: I current, R resistance, V voltage. Sometimes they have E for voltage, but typically you'll see V, but this diagram has E, so just be mindful of that. But basically this shows all the equations. So for example, the way that you would use this is, let's say you had a problem where they gave you resistance and current and asked you to find voltage. You would go into this V where it's red and look at these equations. Okay, this one has an I and R, and that's what I was given. So that's the equation I would use. V equals I times R, and that's the equation. So this is just a way to kind of have all the equations up front. It's the same equations that are here. The only difference is there's also P added for power. So power gets a little bit complicated because it has square roots and squares. We'll talk about that next week. So you can ignore all these equations with P and just focus on these three equations. So if you want to write these down, you can. So that's V equals I times R, I equals V divided by R, and R equals V divided by I. So let's do an example. Let's say you have a current in a circuit, or not a current in a circuit. Let's say you need to find the current in a circuit that has 15 volts and 3 ohms of resistance. Okay, so the way that we would do this is I would look at this. So we're solving for current, we know is I, and we're given resistance and voltage. So we know E is voltage. So it's I equals E or V divided by R. I would use this one. So I equals V divided by R. So if you wrote here, it would just be I again, because I is current, equals V. That pie chart I had has it as E, but I remember it better as V. So V divided by R equals I. And all you have to do is plug in the numbers. So 15 volts, that's our total voltage. 3 ohms is our resistance. 15 divided by 3 is 5. And so 5 amps is the answer. And this is an exact problem you will see on the quiz for competency A, and you'll see it in a lot of different forms. So if you understand this concept, that's a big chunk of competency A, if that makes it feel better. So again, it's just simple math using Ohm's law. And you'll see that we can do a couple more examples where you have to solve for other things. So this is the same thing, but now it says, what is the voltage in a circuit with 200 amps of current and a resistance of 10 ohms? Okay, so this problem is wanting us to solve for voltage with a circuit that is 200 amps and 10 ohms. So we know that we need something that has V equals. And if I go back and look, V equals I times R. Also, you can see it here, V equals I times R. So V equals I, again, I is for current. this problem, sorry. So V equals I times R, where I, it tells us, is 200. And the resistance, it tells us, is 10. So 200 times 10, I have to use my calculator because I'm really bad at doing math in my head. I think it's 2000, but I need my phone to verify. So it is 2000 volts. And that is the answer. Okay, so I'm just going to pause here. Any questions about this concept of using Ohm's law to calculate either voltage, current, or resistance? Or any questions about those three terms, what they are, or their units for it? I see something in the chat. Let's see. No, okay, good. So hopefully that made sense. Wasn't too complicated. You can see here that this is just another example, but it wants you to solve for resistance with a 10-volt battery and a current of 25 amps. You do the same thing. But one thing I did want to touch on in the last 4 minutes is the relationship between these three terms. So when talking about the relationship between different terms in the mathematical sense, you can either say they're inversely related or directly proportionally related. What that means is when something's inversely related, when one goes up, the other goes down. We already talked about how current and resistance are inversely related, right? Because we know that the more resistance we have, the smaller the current, or the slower the current's going to be. So they're inversely related. If we increase the resistance, we're going to decrease the voltage. If we decrease the resistance, we're going to increase the current. I meant current, not voltage. But so essentially, current and resistance are inversely related. An increase or decrease in the other is going to cause the opposite effect in the other term. And you can test this to see how one impacts the other by doing a quick math problem. And that's what we're going to do here. So let's say that we have a circuit with a 5-volt battery and a resistance of 25. What is the current? Okay, so we have current is I. So I equals V times R. You can go back and look at that chart and it would show you this. I think it equals V times R. No, I don't know. So I need to go back and check. I equals V divided by R, and this is why I needed to double check. So I equals V divided by R. So where V is 5 and your resistance is 25. So that means my current is 1/5 amps. So if you get decimals, that's fine. It might not always have a whole number. You'll just have to round up on the quiz, you'll see. But the answers will never be like super close. So 1/5 amps is our current, or if you want that in decimal form, that's 0.2 amps. I'm just gonna write here. So now let's say we increase the voltage to 10. So where it was 5, now it's 10. So 10 divided by 25 is 1. 10 divided by 25 is 0.4. So what happened? So you can see that when we increased our voltage from 5 to 10, it increased our current from 0.2 to 0.4. So by doubling our voltage, we doubled our current. So what that means is that current and voltage are directly related, right? Because when we increase one, it increased the other. So that's something that's directly related. This makes sense, right? Because the greater voltage we have, the greater power, that greater the push, which means the faster those electrons are going to go. Now you can see that if we decrease the resistance from, let's decrease the resistance, it was 25. Let's make the resistance, I don't know, 5. So we'll compare it to this. So 10 divided by 5 now. So a voltage of 10 volts and a resistance of 5 instead of 25. That gives us 2 amps. Okay, so you can see what happened, right? So when we decreased the resistance, we went from 25 to 5, it increased our current from 0.4 all the way to 2. So those are example of, again, being inversely related. When we decrease one, 25 to 5, it increased the other from 0.4 to 2. So you'll see that on the exam for this competency, there's going to be a couple questions that ask you, are voltage and current inversely related? And if you don't remember, you can just do a simple math problem and see what happens if you change one, what happens to the other. But with that, it's already 12:50, so I'm going to pause and just say this is a big chunk of competency A. Next week, we'll kind of finish it off and talk about power, talk a little bit more about some other terminologies like a multimeter and how to use it. And then for week 3, we'll move on to part B. So with that, what I would recommend you do is, give a shot at the quiz. You're not going to know everything because we didn't go over everything, but it kind of gives you an idea of what you still need to learn. If you want to work ahead and, read some of the modules, read some of the materials you're given and take another shot at it, go for it. You can submit the project as many times as you want. Just make sure by the 15th, you've got the first milestone done, ideally done with 100%. So if you want to do it a couple days before then, so I can grade it and make sure everything's good, you can do that. With that, I hope to see you all next Tuesday, 12 to 1. If that time doesn't work, again, we can schedule individual time to talk, and definitely reach out throughout the semester if there's any concerns at all. And yeah, so with that, I will stop talking because I've talked for an hour straight. I know that can get boring. So I'll hand it over to any of you for any questions, concerns. If not, you're free to log off and enjoy the rest of your day. And yeah, look forward to the next 7 weeks. Thanks. All right, I see there's a couple of you left. Feel free to anyone who wants to talk first if you have questions.